Hipsters will be able to graph and recognize the graph and recognize graphs of nonlinear equations. So if we're dealing with nonlinear equations today, what do you expect to be true about all of the equations that we see today? Mr. Resendez. None of them are going to graph a line. Okay, so that's going to be something we're going to expect to see about the graphs of the equations. What about the equations themselves? What do we expect about all of the equations? Judea. He did say that.
They're going to make shapes.
What about the equations themselves, Viviana? What will we expect to see about the... Right, they'll have exponents. Okay, so the next one we have is y equals negative 2x squared. With nonlinear equations, we need to graph more than 3 points, because sometimes when you graph 3 points, they might actually look like those 3 points are in a line. We're going to pick a variety of values. Here we're just going to pick negative 3, negative 2, negative 1, 0, 1, 2, and 3. In the future, however, you will only need to choose 5 points, but I want to use 7 points here just so we get a clear view of what these shapes might look like. All right, so this is y equals negative 2x squared. So for this one, I've got y equals negative 2 times negative 3 squared. That's negative 2 times negative 3 squared. Negative 3 squared is negative 3 times negative 3, which is 9. So this is negative 2 times 9, which means this is negative 18. It's a bad date.
That's the way you did it. I don't like 100.
Next one is y equals to negative 2 times negative 2 squared. Obviously, do the exponent first. Negative 2 squared, that's negative 2 times negative 2 is
4.
Positive 4. So it's negative 2 times positive 4. Negative 2 times positive 4 is
8.
Negative 8.
Oh. Why? There's no... Oh, that is a negative.
Negative 2 times negative 1 squared. Negative 1 squared is 1. So negative 2 times 1. Negative 2 times 1 is?
Negative 2.
Negative 2. Y equals negative 2 times 0 squared. 0 squared is?
0.
Negative 2 times 0 is?
0.
Y equals negative 2 times 1 squared. 1 squared is?
1.
Negative 2 times 1 is?
Negative 2.
2. Y equals negative 2 times 2 squared. 2 squared is?
4.
And negative 2 times 4 is? Negative 8. And finally, y equals negative 2 times 3 squared. 3 squared is?
9.
Negative 2 times 9 is?
Negative 18.
Negative 18. So we'll go over here and graph these points. It is not quite the same thing.
Why?
I'm going to start here with 0, 0. That's my 1 in the middle. 1, negative 2. And negative 1, negative 2. So I've graphed these 3 points so far. Negative 2, negative 8. I'm going to zoom in here a little bit. Negative 2, negative 8. That's over negative 2 and down to negative 8. And negative 3, negative 18. That's over negative 3 and down to negative 18. 2, negative 8. And 3, negative 18. So I've just graphed all 7 points. As we can see, it looks like the shape is similar. We see the slope is getting steeper and steeper as it goes out from the center, which means that as it goes down towards the center here, it's actually going to do the same thing and kind of flatten out and then come back up. Right, so this is not a straight line, so we definitely do not want to use a straight edge. It's a curved line of sorts. All right, so that's our second graph of a nonlinear equation. This was y equals negative 2x squared. All right, next one. Y equals 1/4 x cubed plus 1. For the sake of making the numbers come out a little bit more evenly, I'm going to pick negative 4, negative 2, negative 1, 0, 1, 2, and 4. And we'll work on over here. So this is y equals 1/4 times negative 4 cubed plus 1. Starting with the exponents, that's 1/4 times negative 4 cubed. That's negative 4 times negative 4, which is 16, times negative 4 again is not just 64, it's negative 64. So we have 1/4 times negative 64 plus 1. 1/4 times negative 64 is going to be negative 16.
No, it's negative.
Negative 16 plus 1 is
15.
negative
15.
15.
That's a lot of work.
All right, next one. Y equals 1/4 times negative 2 cubed plus 1. 1/4 times negative 2 cubed. Negative 2 times negative 2 is
4
times negative 2 is
8.
negative 8 plus 1. 1/4 times negative 8, so that's 1/4 times negative 8.
Boom.
Okay, we're going to get some simplification there. 4 looks like it's going to give me not just 2 because it's a bad date, it's a negative 2 plus 1.
Which is a negative 1.
Which is negative 1.
Will there be fractions on the test?
Y equals 1/4 times negative 1 cubed plus 1. Negative 1/4 times positive 1/4 times negative 1 cubed. That's negative 1 times negative 1 is?
1.
Negative 1 times negative 1 is?
1.
And times negative 1 again would be?
Negative 1.
Negative 1. Plus 1. And 1/4 times negative 1. This is where I'm going to say it's okay to go ahead and go into the realm of decimals. So negative 1 times 1/4 is just going to be negative 1/4. And negative 1/4 is the same thing as negative 0.25.
And then you plus 1, so it's
Plus 1. And
0.75.
this is positive 0.75 because the larger number here is
1.
1. Ah, good, 0. 0 is always going to be easier. 1/4 times 0 cubed.
0.
plus 1. 1/4 times 0 cubed, so that's 1/4 times 0 plus 1. 1/4 times 0 is
0.
0 plus 1.
1.
1. Okay, next one. Y equals 1/4 times 1 cubed plus 1. 1 cubed is
1.
1 times 1 times 1 is
1.
okay, so this is 1/4 times 1 plus 1. 1/4 times 1 is
1/4.
1/4, which is positive 0.25 plus 1.
1.25.
0.25 plus 1 is
1.25.
1.25. Y equals 1/4 times 2 cubed plus 1. 1/4 times 2 cubed. 2 cubed is 2 times 2 is
4.
times 2 is
8.
8.
Why am I only going to say it? Which is
1/4 times 8
which is 2.
is positive 2
Haha.
plus 1 is
3. I'm smart for that, I guess.
y equals 1/4 times 4 cubed plus 1. 1/4 times 4 cubed is 4 times 4 is
16.
times 4 again is
64
64. 1/4 times 64
is 16.
plus 1. 1/4 times 64 is 16
Plus 1
plus
is
1.
17.
17.
What the heck?
Like signs that. All right. Now we're going to go ahead and graph these points, starting with -4, -15. That's over -4 and down to -15. So it's way down here.
I found it.
And the next one is -2, -1. So that makes -2, -1. The next one is the one we have to really think about when we're graphing. It's
great.
-1.75. So I'm going to zoom in here a little bit.
Right there.
We have -1 and 0.75. So 0.5 would be in the middle. This would be all the way up to 1. So 0.75 is going to be between 0.5 and 0.75. So it's going to be kind of right here. All right, and the next point is
It's -1. You put it in the 1. Oh, it's going up.
0, 1. Thank you. Almost over 0, up 1. And the next one is over 1, up 1.25. So I'm going to zoom in again here and think about this. If I'm going over 1, up 1, well, 1.5 would be in the middle, so this is 1.25 in between.
This does not look like it.
And over 2, up 3.
What is this?
And over 4, up 17. All right, so we see the same thing seems to be happening. It gets less and less steep as it approaches the center. So the similar thing is going to happen when it gets to the center. So I'm going to zoom in here on the center really quickly. It gets less and less steep, so it's going to kind of make that curve until it comes in kind of right, flattening back out. But then it starts opening back up, but this time it opens up the opposite direction.
Select in the alone time. It's this one.
Okay. Yikes, Sage. Yikes. What do we notice?
That in each of the sections, they are all graphed in the, like in the same way, and
Yeah.
They're all in the quadrant that they're.
Yeah. So in all of the sections, ax cubed, negative ax cubed, ax squared, and negative ax squared, they all have the same shape. So what we know is that anything that is the same type, it has the same general setup, is going to graph at least the same general shape. What else do we notice? Emmanuel. Yeah, so if it's got a positive coefficient over here on the positive ax squared, those seem to face up, and the negative ax squareds, the negative coefficients, seem to face down. Other observations? Emmanuel cannot be the only person making observations today. Judea. Leslie. What's basically facing the same way?
Like those two are all facing this way, and then those two are all facing this way.
Yeah, she's looking at the x cubes, and she's saying the positive coefficient x cubes seem to be facing and ending going kind of upward, and the negative coefficients seem to be facing this way where they're going ending downward. So those are the main observations. Number one, that these seem to make the same shape. Just some of them are up and some of them are down. These seem to make the same shape, but some of them are facing one way and some of them are facing the other way. Okay? What are the actual differences between the equations? There's only two things that change here in these equations, Judea.
When the equation is positive, it goes up, and then when it's negative, it goes the opposite way.
Okay, so she's saying she's seeing a big difference in the coefficient. Whether the coefficient is positive or negative. That's one thing that changes in these equations. The coefficient is positive, or negative. What else changes in the equations themselves? Sunny.
The exponent.
Yeah.
Over the x.
The exponent. So let's talk about what these things mean. Both of these are, what is the general shape of this ax squared? What's the general shape? How would you describe this shape? Leslie.
It's like going downwards and then making a U.
Yeah, it makes a U. So the general shape, anytime we have a positive coefficient and an x squared term, it's going to make a U. In fact, even our negative ax squareds, what shape do they make? They make a U, but it's upside down. Yeah. So generally, we can say anything with with an exponent of 2 is going to make a U, and it rhymes. All right. So that's what I like to say. Coefficient of 2 makes a U. All right, coefficient of 2 makes a U. Now, the positive coefficients, they open up. The way I like to remember this is I like to say, hey, that looks like a smiley face. Positive. Sorry, this should have said exponent of 2. Make sure you actually wrote what I said, not what I wrote. Exponent of 2 makes a U. Positive coefficients smile because they're positive, they're happy. And negative coefficients frown because they're unhappy, they're negative. Okay. All right, so looking over here now at our x cubes. What shapes do these x cubes seem to make? These exponents of 3, what shape do they make? How would you describe that shape, Judea? A slide, a slur. Okay, I like to think about it as a water slide. And that's so I can say exponents of 3, say, we, like you're going down a slide. Now the observation that you made earlier is that Leslie made earlier was these end going up with the positive coefficient and these end going down. So I'm going to make this one end going down. I'm going to make this positive coefficient end going up. So positive coefficients. End up. And negative coefficients. End down. All right.